Welcome back, ladies and gentlemen. This is the 2002 Jeep Grand Cherokee Laredo 4.0. This is going to be part one of a two-part series while I wait on parts to arrive, so I figured I'd get this out of the way. So today we're talking about the radiator fan relay and everything that got us to this point so far. So we took the Jeep on a long road trip, and in this Florida heat we noticed that the air conditioner was not keeping up with the demand. So it was cool-ish, but not really cold. So I got to doing a little bit of digging, and I thought everything was fine. I've got a 5-blade clutch-driven fan, and I figured that this was pulling enough air through the radiator to cool everything down. But apparently it does an adequate job at keeping the engine cool, but it's not enough airflow to cool the air conditioner condenser in the front. So I got to doing a little bit of research, and this is true for this Jeep. It may not be true for all Jeeps, but there is a dual fan system. So if you get in there, you can see an electric fan that sits in front of the belt-driven fan. And I installed that after realizing that this entire Jeep was wired up for an electric fan. So it wasn't supposed to be omitted. So I bought a new fan, I wired it in, lifted up the shroud, installed the electric fan, plugged it into the connector down there, and everything was supposed to be just fine, right? Wrong. Installed everything, hooked it all up, the fan didn't work. So I got to tracing it all the way down and figured out that the relay was bad. So I bought a new relay, installed a new relay, the fan worked momentarily, I blew a new relay, got to doing a little bit of research on this, and I realized that these things get really hot. Ignore this for a moment, this is an experiment, we'll get to that later. But these original relays in here, they just mount behind the passenger side headlight, and they mount directly to the frame. But these get really hot, they blow all the time, and if you do any reviews on these, you realize quickly that a lot of people deal with the same issues. So these little hexagonal flat relays that go in there, they just get hot. I mean, I touched it, and you can boil an egg on that thing. So I got a refund on the one that I bought. It was a cheap, $20 eBay special. So I got a refund, got my money back. I ordered another one, of course. The consensus from a lot of the forums say that those cheaper relays, they blow faster, anywhere from a week up to 6 months. So I took my chances and I bought another one. And it's a better alternative than the $90 Moog part. So I'm gonna give it another shot. But this time I built a heat sink. So I had a scrap piece of aluminum. It's about a 1/2 inch thick, and then I put some heat sink compound on there, drilled the holes, and that will sandwich in between the frame and the new relay, and hopefully that'll dissipate some of the heat and keep it from dying so quickly. I did treat this on the back side, so that way I could avoid some of that galvanic corrosion when steel sits against aluminum. So that'll be attacking it from that front. So I'll get the new relay, sandwich in the heat sink, hopefully that will work. But what we're looking at here is a little science experiment that I did with a relay. So I told myself, there are 4 wires in here, why can't you just use a 4 or 5 blade relay to jumper the fan in the meantime? I mean, it's a pretty simple system, fans shouldn't be that complicated, right? Well, it's a little more complicated than it looks. So I'll go through what I've learned, and hopefully this will help somebody. But just so you know, if you tap into these wires with your own relay, it will not work. So I was counting on a few things, and we'll get into it here. So looking at this relay, right, we'll start from the top here. 1, 2, 3, and 4. So starting from the top, that gray wire, that is the fan ground, right? And so that is grounded out. The second wire from the top is a green wire, heavy gauge green wire. That is the always hot positive to the fan. You connect those 2 wires together, the fan runs perfect, right? The bottom 2 wires here, we're looking at a green for wire number 3 and a black. Those are the signal wires for the relay, and the green wire is the positive signal wire, and then the black is the ground. I've tested all these out, and it makes sense. So all that is how this thing is wired up. So I figured, hey, I could tap into these accordingly and make a little, 30-40 amp 5-blade relay work. Now, when I jumper wire my signal wire here, I'm trying to do this two-handed here. So this is my signal wire. When I jumper that, to the positive wire and close the circuit and make everything work, the fan works. If I connect these two together, the fan comes on, I can hear it, right? The problem is the signal wire, right? So where the signal wire comes from is actually from the PCM, all the way back there. It doesn't create a positive charge enough to close this relay. So I'm thinking why. This is just a very simple relay. The relay that goes here is a really complicated little circuit board. I tore the old one apart and was trying to examine it, and it's a whole circuit board assembly. So what I'm thinking is that signal from the power control module is actually probably some ohm rating or some specific figure that the relay needs in order to close the circuit and make everything work. It's not just as simple as a direct positive connection and, you know, slamming this relay shut. So I left this wired in for a reason, because I didn't cut any wires, I just tapped into them. So these are just splices into the original wires, right? So I can plug in a new relay and the existing wiring is all fine. But now that I know this won't work, I could probably save you guys some time, so don't try this. But what I do have is a manual relay, right? So if I take this PCM off, PCM signal wire off, I still have a functioning relay into the existing wiring, and I can manually turn the fan on and off. So what I'm going to do is get my new relay, sandwich in the heatsink, let it work as it's supposed to work, but in the event that this ever fails and I'm on the road or it's overheating or whatever, I am going to run a new signal wire. Right, detach the old PCM signal wire, run a new signal wire through the firewall, probably go through the input, through where the antenna goes into, and then run it along the dash and do a little switch over here. Haven't decided exactly how I'll run it yet, but I will have a manual switch on the dash that can close that circuit, and I'll probably end up putting it somewhere here, just so I have it. I've got one of those lighted toggle switches on the way, so that way it'll, and it actually says fan override, so I'm going to put that here. It'll be nice. And then that should give us manual options, right? So I'll go through here, have the original, I'll have a manual switch option, and I won't have wires all over the place since I'm going to utilize the existing wiring harness for the fan, and I know it all works. Other fun facts, this might be useful information to anybody doing some troubleshooting. When the fan is operational, I did an amp test. You know, it's the 12 to 13 volts is normal, but when the amp draw starts on this fan, or the startup amperage for that fan, I watched this thing jump up to about 55 amps. And the nominal, just the normal operating amperage, was about 14 amps. So if that helps anybody, that's what a brand new fan, well, hang on, there's ambulance driving by. Let's wait for the sound. So when that electric fan kicks on, momentarily it's going to be 55 amps or less. 40 to 55 is kind of where it initially jumped up, and then it'll stabilize back down to about 14 running amps. So that is, I guess, where it should be for a new fan. I guess as the system gets older and the fan starts to, you know, degrade or wear down, it'll probably start drawing more amps than that, but, you know, if that information helps somebody, cool. Second is, if you're looking for where the power comes to that fan, it is actually through this 40 amp fuse right here. So this is the always on power to the fan. And that's all I've got so far. So hopefully we'll get this sorted out, and I'll get this fan running and get some cooler air conditioning temperatures in here. But my goal for this whole thing was to make sure that I just didn't have wires everywhere. So that was important to me. I didn't want to go too far off the beaten path with, you know, running whole new positive negatives everywhere and different relays, all that. So kind of wanted to use what was there. So far, this is all I've added. I'm going to remove this PCM signal wire because it doesn't close this circuit, and that's about it. So stay tuned for part 2. I'm waiting for the parts to arrive. Once they get here, I'll probably record the install and show you guys what I'm doing here in this area. And then I'll also show you what I'm going to do with that manual switch that I'm installing over on the dash. I'll run a single positive wire over here, and then inside the dash I'll probably tap into the accessories, so that way any manual on-off would not be operational unless the key was on. So that way I don't risk running my battery down while the car is parked and not in operation. So that's the goal. Accessory switch to feed the switch, one single positive power wire to feed this relay, and then I'll have manual options. So stay tuned. I'll show you guys the install and the final outcome once it's all done.